All right, we're going to continue going over the Chapter 2 study guide. This is going to be for learning outcomes. I'm going to actually just do them all the remaining ones, because there's not a ton of numbers with them. So E, F, G, H, and I. E is the first one we're going to do. There's only 3 questions with it, and I know we've done them in class, but it's shoaling. Describe shoaling, so you need a definition, and explain why it's a successful strategy for feeding, reproduction, and predator avoidance. And tuna and sardines are like your main go-to examples that they're going to talk about. Another thing you want to also mention is going to be hydrodynamic efficiency, so saving energy and swimming together. So these are going to be numbers 45, 46, and 47. 45, 46, and 47. And we did these in class together. So 45, discuss the advantages of shoaling in fish like the Peruvian anchoveta, which is an anchovy. So we have the foraging, or your food, your feeding advantage. It helps them in feeding. And this question is a little bit, this question is very open-ended, because it's not specifying which ones you need to talk about. Or if I go to 47, it says specifically for feeding and reproduction. So you can't say shoaling is helpful in feeding. It's telling you it is. Shoaling is helpful in reproduction. That's not going to be a mark. It's telling you that it is. Whereas up here, you could say shoaling helps feeding. Why? Because there's more eyes to spot food. It's easier to corral prey. And I know I spelled corral differently every single time. I think it's 2 R's, 1 L. Or break up your prey shoals, or your bait balls that your prey make. So that's a foraging advantage. There's also predator avoidance advantages. So it helps with predator avoidance, or not being eaten, less predation. Why? Because you have more eyes to spot predators. Large numbers of fish could confuse predators. There's less of a chance of being preyed on as an individual whenever you're in such a big group. I don't know why it's harder, but it is. They're all swimming in a coordinated way. It's harder for fish in a large shoal to be eaten. So other fish will try and break up those shoals and make them into smaller groups. The video I showed in class a couple weeks ago, we saw that. We saw shoaling on both sides. We saw shoaling on the predator side, and then we also saw shoaling on the prey side, and them trying to avoid being eaten. There's reproductive advantages. So it assists in reproduction, or it can assist or help with reproduction. And the reason why, you don't, again, watch your absolutes. There's no guarantee in mating ever. It does not help fertilization. It doesn't help it does help reproduction, but it doesn't cause fertilization. It doesn't guarantee. There's no guarantees. All it is a chance. So it increases the chance of finding a mate. It increases the chance of fertilization. Could also, in that same second mark there, saying you're in closer proximity with mates. But the chance of fertilization, there's no guarantee, because they broadcast spawn, which means they release sperm and eggs into the water and then just hope that they will meet. So yeah, there's just a chance. And then your hydrodynamic advantage. So there is a hydrodynamic advantage that increases hydrodynamic efficiency, which allows them to swim in each other's current and not have to expel as much energy. So it's going to save energy. All right, 46, same answers. Suggest why shoaling can be an advantage. In this one, though, I talked about in class, you could give the definition of shoaling, and that was a mark. In 45, it doesn't, you can't, a mark for the definition is not, it's not there. And this says discuss the advantages. This says suggest why. How do you know if you give a definition or not? I don't know in this situation. Of course, when it says what does it mean by, or define, or explain, yeah, go definition. But I would say when in doubt, put a definition. You're only going to get it wrong if that's a wrong definition. You're not going to lose marks for it, though. But if it's part of the key, if it's part of the mark scheme, which is like the answer key, then that's awesome. But between 45 and 46, I don't know why one you can give it a definition and one can't. They are from different testing years, and it is different people writing the test and the answers. So when in doubt, give a definition. Same answers though. You have a definition, you have your hydrodynamic efficiency, avoiding predation, foraging advantages, reproductive advantages. And this one is specifically for feeding and reproduction. So explain why this is a successful strategy for feeding and reproduction with reference to tuna. So predator avoidance is not anything you need to mention. You can talk about hydrodynamic efficiency because that does help with feeding. You don't have to expel as much energy whenever you're looking for food. So there's hydrodynamic efficiency. They can swim faster. It'll save them energy. And the time taken to find food goes down. Shoaling can also help split up bait balls or corral the prey. And there's many eyes that can spot prey. So that helps. And the reproductive advantages against males and females can shoal together. There's a higher chance of finding a mate, and then there's a higher chance of fertilization. So that's going to be it for learning outcome E. Learning outcome F is explain the meaning of the term succession. Give examples, including tube worms, Tevnia, and Riftia. Those are going to be number 17, 30, 35, 43, and 44. I'm going to 17. Okay, so this question said with reference to tube worms, which you have to know anyways from the learning outcome, found at hydrothermal vents, explain the meaning of the following terms. So explain, definitely give a definition and an example. So succession is a change in a community. And a community is all of your living things. So a change in your community over time. The succession definition is typically 2 marks. Change in like the species that live there, or change in your community over time. And then your example, Tevnia gets replaced by Riftia. T gets replaced by R. That's okay. That's Tevnia goes to Riftia. Tevnia goes to Riftia. 30. Explain the meaning of the following terms in ecology. Give one example. So again, succession, change in a community structure over time. Example, Tevnia gets replaced by Riftia at a hydrothermal vent. You could talk about succession on a whale carcass. Succession at coral reefs. Coral reef is chapter 5, and you guys will know really well. There's 4 steps in creating an atoll or like a coral reef formation. And yeah, we'll talk about that then, but also like how the initial corals like start to come there. Like they will inhabit like barren land, like solidified magma. Corals can start growing on there, and then as long as you have zooxanthellae around, they can start to do their thing. Cool. 35. Same thing with reference to specific examples. Explain the meaning. So you've seen this a lot. Some people don't put the emphasis on vocab that they need in this class. This is why I give vocab quizzes so often. You have like 2 or 3 a month. So often you're going to have a vocab quiz because the definitions are, and you can't make them up. Like you have to know them and you have to write them. It's not going to be matching on your Cambridge test. But succession is a change in a community structure over time, 2 marks. And then you need a marine example. Could be succession at a hydrothermal vent, could be the whale fall succession. And you have like different types of tube worms and crabs and organisms living there. Different types of like shelled organisms as well. I feel like the day's been so long, I don't remember what I'm doing. 43. Explain what is meant by the term succession. Change in community structure over time. And though it even says explain, it could have just said define, or it could just say what is meant by the term succession. There is really no explanation involved in this at all. I hope that you can see like these inconsistencies that I point out, that they're humans that write these tests, and mistakes can happen, but explain really, it's not an explain command. It's just a definition. If I saw this, I would be like definition and example, but that's not part of the mark scheme. And it is a 2 mark definition I just know that. Don't be like, how does she know that? How am I going to know which one's 2 marks, which one's not? I know that because like I study the answers. Reading it out of the book, no, you would never know that, but that is part of it. If you know the definition, changing a community structure over time, you'll get both marks. You don't have to be thinking this is a 2-mark definition, or you'll get both marks over it. If I were taking this and I didn't know, I would put the definition and then I would put an example, but an example isn't part of it. I went too far. Okay, and then one example of succession. I drew it for you. Hydrothermal vent, and we have to outline. So outline, you give like, you can bullet it, but you give like in a list, a sequential order. So vent bacteria are going to be like your first species there, the pioneer species, the first organism. And then mollusks, which are shells, and tube worms will follow. Referencing Tevnia will get you a mark. And then it's replaced by Riftia will get you a mark. You could also talk about the whale fall succession example. Oh, excuse me. Cool. That's it for 44. Okay. Now we're going to do learning outcome G. Understand why extreme and unstable environments, that we talked about in class today, extreme like your hydrothermal vent, unstable like the sandy reef slope. Understand why extreme and unstable environments tend to have relatively low biodiversity. Giving examples that include coral reefs that are stable and not extreme, sand on a reef slope, which are unstable, and hydrothermal vents, which are extreme. And then the other one we need to know, it's not in your learning outcome, but I know you need to know it, is the rocky shore. And I don't know why it's not in here, but you have to know it. That's going to be numbers 14 and 15. Oh, we did this in class. So just like what makes them extreme. Yeah, we did these in class. 2 features that classify them as extreme: really hot water temperature at the vent. It's very cold surrounding it. Their temperature ranges are from, what did I say? 2 degrees Celsius to 400 degrees Celsius. There's really high water pressure, about 300 atmospheres. Low oxygen concentration, so it's hypoxic. Hypoxic means like hypo versus hyper. Hypo means less than. So hypoxic means less oxygen. Anoxic, with an A in the front, A-N, anoxic, means no oxygen. So remember, A or A-N in front of something means not, but so anoxic is not oxygenated at all. All right, there's no light, so not little to no light, no light. There's high hydrogen sulfide levels, and there's low pH. Same thing with this one, except it said just physical properties, so not chemical, no pH things. High water temperature, high pressure, and then it's aphotic, which means no sunlight. H, give examples of organisms that occupy specialized and generalized niches. Again, just off the top of your head, and just throwing it out there. Specialized niche are going to be held by organisms that live in places that are very biodiverse. Generalized niche are going to be for organisms that do not live in places that are very biodiverse. That's it. It include examples that are coral-eating butterfly fish and tuna. Tuna, generalized niche. It can live in multiple places. It can eat multiple food items. Your coral-eating butterfly fish lives in a coral reef ecosystem, so very specialized, and it eats corals. Can't live in multiple types of conditions. It can only live in that kind of environment. That's 14 and 15. I did it. Oh, no, sorry. 14. I'm sorry. I'm almost done, and I'm going to go home. 14 and 15 were for G. So H is the specialized and generalized niche. It's 8, 32, and 58. Okay. Oh, cool. That's a fun one. So for 8, there's 3 different ecotypes of killer whales in figure 3.1. Which one has a generalized niche, and what is the advantage of it? So an organism that has a generalized niche can live in multiple habitats, it can have multiple food sources, and it can live in a variety of conditions like temperature, depth, salinity. So there's 3 different types. Let's look at them. So we see the food web, and it's in the Ross Sea, which is like in the north. And so we know they're in the same habitat. So we don't know anything about their habitat. We just have a food web. So all you can really infer from this are their food sources. We don't know the depth or the temperature, ranges they can live in, but all you know is their food sources. And luckily that's enough because food sources are a part of a generalized niche. Here's our 3. Ecotype A, ecotype B, and ecotype C. Ecotype A feeds off the minke whales. Ecotype B feeds off crab eater seals, emperor penguins, and Weddell seals. And ecotype C can feed off the Antarctic toothfish. And that's it. So the only one that's different is ecotype B. It has 3 food sources. So I showed the arrows coming in there. And that's an advantage because it can eat multiple food sources. So ecotype B, why? Because it has a variety of food sources. And then just knowing about having a generalized niche, we know that you also can live in multiple areas. 32 and then 58. And we have one left. All right, so we see a butterfly fish. Butterfly fish are examples of organisms that have a specialized niche, and they have a specific habitat, specific food source, specific water conditions. Some marine organisms occupy general niches. Using a named example, tuna or sharks, like those should be your go-tos. Using a named example, explain what is meant by the term general ecologized niche, or general ecological niche. So your definition is the role of an organism. That's your niche. But this organism is not specific to any type of habitat or food chain. It's not. Like, it can live multiple places. Another way you can say this, and I have it at the bottom, and this is the one that I've memorized, is a general ecological niche is held by an organism. So it's not a thing. It's like a position that you fill. It's like I can't give you a general niche. Like it's just like a position that you fill. So it's held by an organism that can exploit a wide range of food sources, habitats, and conditions. I've literally said that now so many times for the past 3 years. That's the definition I will always remember. So a general niche is held by an organism that can exploit, which means take advantage of, a variety of food sources, habitats, and water conditions. Example, tuna, shark, sardines, nematodes. 58. Just definition. Okay. Dog whelks are mollusks found on rocky shores. They adhere to the surface of rocks with a muscular foot. Dog whelks are predators. This is the dog whelk. They feed on other species of mollusks and on barnacles. If you're a mollusk, it means you have a shell. With reference to dog whelks, and they just told you what they are, what is meant by the term niche? So we need to give the definition, so the role of an organism, and then reference it to dog whelks. So all we know exactly what it told us. They're predators that feed on mollusks and barnacles. So that's it. A dog whelk is a predator that feeds on other mollusks and barnacles. I'm gonna show you something cool. Give me 1 second. Okay, so I think it was this summer. Actually, I think it was like the end of last year. Doesn't matter. Within the past year, I found this on the beach, and initially I was like, what kind of plastic crap is this? And it's not plastic. Can you hear it? It's a maraca. No, it's not a maraca. These are the egg casing for baby dog whelks. These are them. Like humans have their babies in an amniotic sac with placenta, and this is what the dog whelk makes. It's crazy. If you look up videos, like dog whelk laying eggs or laying its egg casing, like outside of the shell, like it like creates this. This is not a dog whelk. This is not a dog whelk, but a dog whelk does have like this similar shape. It literally like produces it out of here. It's really strange. But these are the egg casing. It's the new babies. It's the new little dog whelk babies. And let me open one up, and then we can see on the inside. Okay, cool. I'll try and do it here. We can see on the inside like what they look like if I don't break it. I have a couple. Isn't that great? You can hear them. Their babies are in the inside. And then we have one more question to do after this, but did I already take it out? Is it empty? Sand. Okay, I see some in here. I think I just smashed one. Shoot. Yes, okay. It is like a tiny little spiral baby. Can I zoom in any closer to that? I can. Okay. Okay, hold on. Oh my gosh, no, I'm not going to do this to myself. I won't do it. All right. How can I show you without dropping it? I don't know if you can see that it makes like a little spiral shape. Oh, it's in my keyboard. That's it. But it is like this tiny, sweet little like spiral little baby. This is hard to show. Yes, okay, good. That's a good angle. That's a good angle. A good angle around there. Yeah, isn't that cute? And so there's like multiple little ones inside. You can hear them. So that's what those are. So it's not plastic, and they're dog whelk babies. How fun. How do I make it small? Great. All right, let's do our last one. Oh, I want to go home. I don't want to go over this question. I don't want to do it. You can. I don't want to. I just don't want to talk about it. This big one I didn't put in the answers because I would much rather do it together. I'd much rather do it together. Okay. The money shot. So I talked about this in all classes today, about the coral reefs. Okay, so explain why coral reefs tend to contain narrow ecological niches. This is like always asked. This question is big. Yes, all right. So you want to start with, you can start with the definition if you want, but you definitely want to start with biodiversity. Corals have a lot of biodiversity because right there you're saying there's a need. There are so many organisms there that we are going to have, like there's a need to now specialize it. Again, think about New York City. If somebody's in your parking spot, what's going to happen? Is it cool? If somebody goes into your apartment because they don't have a place to live, is that cool? No. If somebody goes in your fridge because they don't have food, is that cool? No. Somebody's in no. So, if somebody's in your parking spot and you're like, I don't know, my hometown, Mentor, Ohio, it's probably not gonna be that big of a deal. You go to another parking spot. It's not limited. But there's a lot of limits in like coral reefs because there's so many organisms. So you want to like address it like, boom, there's a lot of organisms. That is your reason why we're going to have to make it very specialized, very narrow niches, no overlap. Okay, so corals have a high biodiversity. They also have a large number of niches and food and habitats that can be there. So that like brings in organisms. A niche is an organism's role in the ecosystem. So go definition. An example. You can give an example. So like when in doubt, go definition. When in doubt, give an example. An example is a coral eating butterfly fish or any coral reef organism. A leatherback sea turtle. Mimic octopus. Zooxanthellae. You have to know zooxanthellae. So that could also be your example. Brain coral. All of the organisms that live there, regardless of who they are, like they have specialized niches. Now the reason why they do, because having narrow niches can decrease competition. And why does it? So it's like saying everybody having their own parking spot decreases fights in the parking lot. Having a narrow niche stops competition. Well, competition for what? What would they compete over? Because you're explaining. They could compete over food. They can compete over habitat. They can compete over mates. And with having these narrow niches, they don't overlap. You don't have some organisms that can do this, this, and this. They're not taking over anybody else's role. If, 3 people each have their own parking spot, the first person doesn't get to pick, out of those 3 parking spots. No, like this is yours, and this is yours. You don't get to start spreading out, parking your car sideways, parking between the lines. Like, no, you're not doing that. And then if you reference the competitive exclusion example from remember from regular bio, you can also get another mark for that. Competitive exclusion principle is that no 2 species can occupy the same niche in the same place at the same time. Or there'll be competition and one will have to leave or one will die. So no 2 species can be doing the same thing at the same place at the same time. Or someone's going to have to leave, somebody's going to die. Ecologically speaking. That's it, man. That's it. And, yeah, awesome. Hopefully this helps. If not, send me a message.